first one is yung magiging discussion outline natin. Uh, we'll discuss about the course outline, the grading system, and then the requirements, and then your resources or the resources that we would be using for this subject. Okay. So first for the course outline. So the course outline includes yung first introduction to data structures and algorithms, and then data structures versus algorithms. So we'll be discussing the difference about data structures and algorithms. Second, the role of algorithms in computing. Third, the big O notation, and then the pseudocodes. I think familiar naman kayo dito, supposedly. Tama ba?
Yes po, sir.
The next one would be elementary data types, would be the arrays, structures, and pointers, which I think some of these topics familiar na kayo since nag-start na kayo with your programming subjects. And then after the elementary data types, we will be discussing about the abstract data types, which are the linked lists, stacks, and queues. Okay. And then for the last part, we would be discussing about the sorting and searching techniques. You have the sorting algorithms and then the searching algorithms. And then the nonlinear data structures, which are the trees and the graphs. Okay. So next one, we would be discussing about the grading system. For your grading system, you have midterm examination, which is 20% of your grade, and then the final examination, 20% of your grade. The quizzes, 20% of your grade, and then the class standing is 25% of your grade. And then lastly would be the culminating activities, would be 50% of your grade. And then passing would be 60% of your grade, zero based. So this would be how would we computing your grade? So yung midterm exam nyo for 20%, kung makakuha kayo ng 50, ang zero base grade niya is 10, and then for the final examination for 20%, kung makuha kayo ng 50, zero base grade niya would be 10, and then your quizzes for 20%, kung makuha kayo ng grade of 100, ang zero base grade niya would be 20. And then yung class standing niya for 25, kung makakuha kayo ng 95, ang zero base grade niya would be 73.75. And then culminating activities would be 15%. Kung makuha kayo ng grade na 100, ang zero base grade niya would be 15, and then yung total niya is 78.75. Tapos applying the formula, zero base grade times 0.625 plus 37.5, ang grade niya would be 86.71, which is kapag tinransmute natin, magkakaroon kayo ng 2.0 na grade. Okay? Clear ba?
Yes po, sir.
Yes po, sir.
Opo, sir.
Clear naman. Okay. So sa requirement natin, isa lang ang requirement natin. So at the end of the term, or at the end of the semester, you have to submit a simple program showing all these class principles. So lahat ng na-discuss natin earlier na principle sa topics, required kayo magpasa. Okay? In terms of kung anong programming language ang gagamitin nyo, kayong bahala. Ang kailangan ko lang yung executable file, okay, and then the source code showing kung ano yung laman ng program nyo. Question? Wala naman. Okay. Walang question ah. And then for your resources, ito yung mga resources natin. You have Handbook of Data Structures and Application by Meta and Sanhi. And then Introduction to Algorithms, third edition, Cormen, Laserson, Rivers and Stein. And then Data Structures and Algorithms, annotated reference with example, first edition, Barnett and Tong. Okay. So ito yung mga resources natin. Available naman ito sa web. You could download it, search for it and download it. Right. Clear?
Yes, sir. Sir.
Yes
Clear,
po.
sir. Okay. So with that, mag-start tayo ng first discussion natin. Okay. So for our first topic, okay, so this is Introduction to Data Structures and Algorithms. Okay. So yung topics na i-cover natin would be data structures versus algorithms, role of algorithms in computing, big O notation, and then pseudocodes. For data structures and algorithms, so let's define first data structure. So data structure is a way to store and organize data in order to facilitate access and modification. So it is used to denote a particular way of organizing data for types of operations. So sample of data structures. So the first one is animal classification. So we classify animals by kingdom, phylum, class, order, family, genus, and then species. So this is a sample of a data structure. And then the second example would be a book composition. So a book is composed of chapters, and then each chapter is composed of a section, and then each section is composed of subsections. Clear?
Yes po. Yes
Okay.
po.
Yes po.
So that is a data structure. And then an algorithm, on the other hand, is a finite sequence of instructions, each of which has a clear meaning and can be performed with a finite amount of effort in a finite length of time. So a simple set of instructions to be followed to solve a particular or a problem. Okay. And also an algorithm is defined as a sequence of computational steps that transforms the input into output, or a tool for solving a well-defined computational problem. Okay. So an example of an algorithm would be email checking or validation. So email checking or validation consists of steps, so from start to end. And then each step contains an instruction on what a particular user or a process is doing. Okay, so for instance, step 1, start. Step 2, create a variable to receive a user's email address. Step 3, clear the variable in case it's not empty, or ask the user for an email address. 5, store the response in a variable. 6, check the stored response to see if it's a valid email. Step 7, not to go back, or not valid, go back to step 3, and then end. Okay. And then another example of an algorithm is baking a cake. So for this one, your problem is baking a cake. How would you bake a cake? So how would you solve that problem? You have a start until the end. So start, second, preheat the oven, prepare baking pan, beat the butter and sugar, mix them with flour, eggs, and essence, vanilla. And then 6, pour the dough into baking pan. And then 7, put the pan into the oven, and then end. Okay? Next one. So we have the roles of algorithms in computing. Okay. So roles of algorithms in computing. This discusses about what particular contribution of algorithms in computing. So the first one, we have the Human Genome Project. So an algorithm identifies all 100,000 genes in human DNA. Second, it determines the sequence of 3 billion chemical base pairs that make up a human DNA. Okay. Second, the internet. So it enables people all around the world to quickly access and retrieve large amounts of information. Sites on the internet can manage and manipulate this large volume of data. Third is electronic commerce. So the core of technologies used in electronic commerce include public key cryptography and digital signatures, which are based on numerical algorithms and number theories. And also, algorithms contributes to manufacture in other commercial enterprises. Okay? So it allocates scarce resource in the most beneficial way. Okay? So yung use ng algorithms natin does not only include sa computer technology. So marami siyang contribution for other fields, not just in computing. Okay. And then furthermore, it shows how to solve specific problems. So for instance, determine the shortest route. So given a roadmap in which a distance is between each pair of adjacent intersection is marked. Okay. And then also finding the common subsequence. If you have X and Y, and then you have a subsequence of X and Y, so it can find common subsequences of those X and Y. Okay. And then algorithms as technology. Okay. So the first one is for algorithms and technology, we measure algorithms by means of efficiency. So different algorithms devised to solve the same problem often differ dramatically in their efficiency. So we have different kinds of algorithms available. Then those algorithms somehow or sometimes fall in the same category. So for instance, marami tayong sorting or searching algorithms. However, it all what do you call it? It all performs the same. So by performing, I mean if you have for instance, you have 6 kinds of sorting algorithms, lahat ng algorithms na yon performs sorting. Okay? However, yung efficiency niya or how it behaves differ based on the problem size of the input, or sometimes it based on hardwares, however, in terms of algorithms, we only measure them by its process. Okay, 'di ba? For instance, nag-execute kayo ng program. Okay, so yung pag-execute nyo ng program, usually or most of the times, dalawa yung factors nyo in terms of speed. The first one, yung software nyo. By software, I mean yung code, kung saan platform nyo siya ginawa. Okay? And then, the second one is yung hardware nyo. Gaano ba kabilis yung hardware nyo? Okay? Anong klaseng memory, anong processor ang gamit nyo, and all. Okay? So, yun yung dalawang factor kapag nag-execute kayo ng program. However, in terms of algorithms, ang tinitignan lang natin is yung process nyo, kung paano nyo di-devise yung software nyo or yung program nyo. Okay? And also by efficiency, these differences can be much more significant than differences due to hardware and software. Okay? So yun nga, ang tinitignan lang natin dito sa algorithms would be yung process nyo sa pag-devise ng program nyo or ng code. Okay? And then, for instance, meron kayong dalawang klaseng sorting algorithm. So, the first kind of sorting algorithm, which will be discussed during the sorting process or sorting topics. The first one is insertion sort. So it takes roughly equal to C sub 1 n squared to sort n items, where C sub 1 is a constant that does not depend on n. That is, it takes time roughly proportional to n squared. And then for merge sort, it takes roughly equal to C sub 2 n log n, where log n stands for log 2, log sub 2 n, and C sub 2 is another constant that does not depend on n. So, ito yung C sub 1 n squared, ito yung running time ng insertion sort. And then C sub 2 n log n is yung running time ng merge sort. Ito yung mini-measure natin in terms of algorithm, yung running time nila. Okay? So, for a concrete example, so let us fit a faster computer A running insertion sort against a slower computer B running merge sort. So, they each must sort an array of 10 million numbers. Okay, suppose that a computer A executes 10 billion instructions per second faster than any single sequential computer at the time of this writing, and computer B executes only 10 million instructions per second. So that computer A is 1,000 times faster than computer B in raw computing power. To make the difference even more dramatic, suppose that the world's craftiest programmer codes insertion sort in machine language for computer A, and the resulting code requires 2n squared instruction to sort n numbers. And then suppose further that just an average programmer implements merge sort using a high-level language with an inefficient compiler, with resulting code taking 50 n log n instructions. So to sort 10 million numbers, computer A takes 20,000 seconds to sort yung 10 million numbers nyo. While to sort 10 million numbers for computer B, it takes 1,163 seconds, less than 20 minutes. So, kahit yung difference niya in hardware, malaki. However, if you could maximize yung algorithms in a way na it would be beneficial dun sa need nyo for a particular problem, mayroon siyang difference kahit na the same yung algorithm or the same na sorting algorithms yung ginagamit nyo. Depende siya sa classification ng data na meron kayo. Okay? Or minsan kasi merong mga algorithms na wherein if for sorting algorithms, kung small lang yung number niya, mas mabilis siya na nagbe-behave. However, kapag dumadami na yung size niyo or kapag lumalaki yung size niyo, bumabagal siya compared to the other algorithms, right? So by using an algorithm whose running time grows more slowly, even with a poor compiler, computer B runs more than 17 times faster than computer A. And then the advantage of merge sort is even more pronounced when we sort 100 million numbers, where insertion sort takes more than 23 days. Merge sort takes under 4 hours in general as a problem size increases. So that's the relative advantage of merge sort. Okay? Clear ba tayo doon? So when it comes to algorithms, we have different kinds of algorithms that falls in the same classification. However, depending on the problem size, depending kung anong i-address yung issue, magiging beneficial yung one kind of algorithm to the other. Okay. So next one would be big O notation. Familiar na ba kayo dito sa big O notation?
Hindi pa po.
Hindi pa po, sir.
Hindi pa na-discuss sa inyo. Okay.
Hindi.
So, moving forward kasi more of the algorithms, when we discuss about algorithms, more of math problem siya. Okay. So, makikita niyo dito on the latter part na itong subject, or I mean on the latter part ng discussion natin. Yung mga functions na discuss, I think, sa mga calculus nyo. Yan, di ba nasimulan natin sa running time ng merge sort and insertion sort, yung mga functions, f of n and then log of n, so yung mga logarithmic functions and then quadratic, cubic functions, those are discussed under big O notation. Okay. However, hindi naman natin kayo pagko-computein ng math. Okay. So, i-discuss lang natin for your reference lang. Okay. So, for big O notation, it is an asymptotic notation. So, it describes the behavior of time or space complexity for large instance of characteristics. So, that's why na-discuss natin yung running time ng merge sort and insertion sort. Kasi we are more concerned with the its behavior for the time or space complexity, okay, per large instance. Okay, that's why yung numbers natin is by millions of numbers. Okay, hindi lang siya small amount of number. Okay, clear? So the notation for asymptotic notation is f of n is big O of g of n. Okay, so yan, nakita nyo yan, f of n is equals to O, G, n is read as f of n is big O of g of n. Means that f of n is asymptotically smaller than or equal to g of n. Okay. Familiar ba kayo dun sa asymptotic na behavior? supposedly na-discuss ko sa math nyo. Hindi ko alam if it's discrete math or calculus nyo. Okay? Kapag sabi natin asymptotic, yung isang number is, or isang function, ibig sabihin ano siya? Kapag asymptotic siya, ibig sabihin, it runs closely, pero it never met. Okay? So, lagi silang malapit or lumalapit sila sa isa sa given na two numbers or two function. Pag asymptotic yung relationship nila, they run closely, pero they never met. Okay? So, for big O notation, so it used for runtime complexity analysis, it describes the worst case scenario and can be used to describe the execution time required or the space used by an algorithm. So, describe lang niya yung worst case scenario, okay? Kasi when we speak of running time, hindi naman natin usually discuss yung best case scenario. Like for instance, kung yung minimum time required niya na to run an algorithm or to run a process, hindi natin concerned yon. Kasi ang concern natin in terms of computing, yung processing ng computing, is yung worst case scenario niya wherein gaano ba katagal pagpa-process ang isang function or ang isang code per se, given na ganito ka-complex or ganito kalaki yung input mo. Okay? So we have different or most common big O notation. The first one is constant. So it describes an algorithm that will always execute in the same time or space regardless of the size of the input data set. So the operation does not depend on the size of its input. Okay, so for this one, kahit ano yung input mo, kahit gaano kalaki yung input mo, constant lang yung magiging execution niya. Okay? So ano yung example ng constant function? So usually pag constant siya, ganito yung magiging form niya. A equals B plus C. So kahit anong value ng B or ng C mo, i-execute lang siya ng process at a constant time. Okay? So that is O1. Okay? So yun yung nagde-denote ng constant function. Okay? And then the next kind is ON or linear. So it describes an algorithm whose performance will grow linearly and in direct proportion to the size of the input data set. So the runtime complexity is proportionate to the size of N. So habang malaki or habang lumalaki yung size ng N nyo or yung input nyo, mas lumalaki yung running time nyo, mas in a way, mas bumabagal yung pagpa-process nyo ng nung input nyo. Okay, so habang lumalaki yung input nyo, mas lumalaki yung time ng pagpa-process nyo sa kanya. Okay. So a sample of a linear function or a linear algorithm would be in this format. Okay. So double max is equal to A0 or yung array ng 0. So meron kayong looping inside. So you have for int I is equals to 1. I is less than N. And then I plus plus. Okay. If A of I is greater than the max, and then max is equals to A of I. So this is a form of a linear, it is this particular block of code is in a form of a linear notation. Okay. Next kind is O log n or logarithmic. So it is very slower than a constant time program, normally associated with algorithms that break the problem into smaller pieces or smaller chunks per invocation. So a sample of a logarithmic notation would be a binary search algorithm. So ganyan yung form niya. Kapag binary search, pag nagpa-perform ka ng binary searching, okay, dinidivide mo yung input mo into 2. Kaya siya binary, di ba? Pag binary, 0s and 1 lang. So, lagi mong dinidivide yung isang block of code mo or isang block ng input mo into 2 kapag nakakuha ka nun. Kapag nakakuha ka ng isang block of code, dinivide mo siya sa 2. Kapag yung resulting nun, i-divide mo ulit sa 2 hanggang sa makita mo yung item na hinahanap mo since this is a searching algorithm. Okay? Gets nyo ba yung idea? That's why it is a form of a logarithmic function or notation. Okay? The next kind is O n log n or arithmetic. Okay, so it describes program whose running time for a problem of size n has order of growth n log n. So taking up to time proportional to n log n to run on inputs of size n. Okay. An example of logarithmic function is a merge algorithm. So merge sort ibig sabihin given an input, yung pagpa-process niya is by merging. So first is supposedly dinidivide niya yung paghiwalayin niya yung function into smaller bits and then isusort niya yung half and then another half and then i-combine niya in a way na pag na-combine niya, once na na-merge niya, it is sorted already. Okay? So that is a sample of a logarithmic algorithm. And then the next one is quadratic algorithm. So this is in a form of ON squared. So it represents an algorithm whose performance is directly proportional to the square size of the input data. Okay. So a sample of this one would be in this form. So for loops or a loop inside a loop. Okay. And then the next one would be cubic algorithms. So it's a typical program whose running time has order of growth of n cube, has 3 nested for loops used for some calculation involving triples of n. So this is an example of a cubic algorithm. And then lastly, we have O2n exponential. So exponential algorithms are extremely slow. You will never run one of them to completion for a large problem. So I don't have an example for this one since this is the most rare common or the most rare type of algorithm. So in Bigo notation, ito yung pag pinlat natin yung running time nila. Ito yung magiging difference. So for dito sa kabila makikita nyo pag constant siya and dito din sa left side and then the right side. Okay, ang difference lang kasi nung nasa left side sa right side, meron tayong exponential and then cubic. Okay, and then logarithmic. So kung makikita nyo, for So, kung makikita nyo dito, for constant, ito lang siya. For constant, makikita nyo siya na steady lang siya. So, straight line lang siya. Kahit anong klase, kahit gano'ng kalaki yung input nyo, yung time required niya, constant lang. Okay? Kapag logarithmic naman, meron kang konting deviation compared habang lumalaki yung input mo compared sa constant. So it's the same way as dito sa right side. Okay? And then, kapag, for instance, kapag exponential, cubic, or quadratic, okay, nag-i-increase dramatically yung time required to run an algorithm depending dun sa input nyo. Okay? Pag logarithmic naman and then linear, okay, makikita nyo na steady lang yung pag-run niya. Habang lumalaki lang yung input mo, tumatagal din yung running time mo. So it's directly proportional to your input size. Okay? Clear ba?
Yes, sir.
Yes po, sir.
So for the last topic that we have for today is pseudocodes. So pseudocodes, supposedly, I think familiar naman kayo. Familiar ba kayo sa pseudocodes or hindi?
Hindi po.
Hindi. Pero nakapag-program na kayo.
Opo.
When we speak of pseudocodes, pseudocodes is a plain language description of steps in an algorithm or another system. So often uses structural conventions of normal programming language, but is intended for human reading rather than machine language or machine reading. Okay, so for the most part, interpreting pseudocodes is trivial as it looks very much like for a more abstract of C++ or C#. Okay. So meron tayong what do you call this? Parang for it to be a pseudocode, meron tayong first one is preconditions. Preconditions should always be informed or enforced. And then post conditions represent the result of applying algorithm to a data structured. And then the type of parameter is inferred. So ibig sabihin, regardless kung anong klaseng input siya, hindi nyo na kailangan i-define. More of inference lang, i-associate nyo lang yung input type depending dun sa process na ginagawa niya. Okay? And then, all primitive language constructs are explicitly begun and ended. So, supposedly laging may start and end. Okay? So, all algorithm starts with a simple signature. So, example, an algorithm name, arguments, kung ano yung mga arguments nyo, and then yung process inside it, and then end algorithm name. So immediately after an algorithm signature, release any pre or post conditions. Okay. So first, meron kayong algorithm name, meron kayong preconditions. So a value, n is a value to compute for a factorial of n greater than or equals to 0. And then yung post condition nyo will be the factorial of n has been computed. And then the process and then the end. So for example, this one, an algorithm of add value. Meron kayong precondition na value is a value to add to the list, and then the post would be value has been placed at the trail of the list. Okay, then you have the process. So n, yung value na ibibigay nyo would be yung node value, and then if head is greater than or is equal to 0, yung n value ilalagay nyo sa head, and then yung n value ilalagay nyo sa tail. Else, yung tail dot next, doon nyo ilalagay yung n value. And then the trail would be the n value, and if, and add. Okay? Or pwede rin siyang ganito. You have pseudocode na program clean the fridge. So for each item in the fridge, you have to do the following. So if the item is rotten, then throw away the item. Else, put the item back in the fridge and then make dinner. And okay. So all this type, itong dalawang to, the same lang siya. It is a pseudocode. So when we speak of pseudocodes, okay, you speak of the process. You describe the process in a manner na it is readable to the general public. Okay, so it's not a technical or programming type of coding process. You just have to describe ano yung process na ginagawa niya. Ano yung ginagawa niya per se. Okay? So each step kailangan clear siya. And then also if magkakaroon kayo ng mga conditional statements or yung i-compare niyo yung mga if conditions and then mga looping statements, supposedly properly ended siya para malaman natin kung saan nag-start at nag-end yung isang particular process or isang particular block of code. Kasi unlike kapag dinescribe nyo siya or kinode nyo siya or ni-write nyo siya in programmatically, when you use syntax of a particular programming language, meron na silang start or end marker. So usually naka-bracket siya or naka-curly braces siya kapag in-start niyo siya. However, when we speak of pseudocodes, babasahin nyo kasi siya in an English-like manner. So supposedly, naiintindihan siya kahit walang background yung magbabasa sa programming. Okay? Clear ba?
Yes, sir.
Yes po, sir.
Questions? May questions ba kayo? Walang may question. Okay. So for this one, since yun na yung end ng topic natin, okay, I'll be giving you guys something to work with for the next part natin. Since yung next part natin would be yung laboratory nyo. And for now, kasi wala pa naman tayong laboratory since principles lang siya. I'll give you guys something to work with para meron tayong task for the laboratory. Okay? Wala kayong questions, clarifications, violent reactions for this one.
Wala pa naman po, sir.
Lahat ba clear? Kasi on the latter part of the discussion, um, i-describe lang natin yung kung ano yung ginagawa. Hindi ko kayo tuturuan kung paano gawin yung isang bagay. Like for instance, let's say arrays. Di-describe lang natin kung ano yung mga process ng arrays, which is I think meron naman na kayong background since nag-programming naman kayo. Okay? Hindi natin covered kung ano yung what do you call this? Technical description or kung paano niyo siya gagawin a specific programming language. It's more of for this subject, i-describe natin yung process niya. Okay. So, hindi kayo makakuha sa akin ng, for instance, for Java, ganito yung pag-i-implement ng array. For C#, ganito nyo siya i-implement, and other programming language there is. Kasi if ganun, masyadong marami tayong programming languages, and though they are somewhat similar, syempre meron pa ring differences yan when it terms of the functions or the processes involved on a particular array, okay? So meron, for some programming languages, yung mga processes involved, like yung sort, meron na silang function, that sort, okay? Pero for this one, i-discuss natin ano yung mga different kinds of sorting algorithms, ano yung different kinds of searching algorithms. Hindi tayo gagamit ng functions of a programming language. Okay. So more of description siya. Okay. Clear ba?
Yes po.
Yes po.
Okay. Clear ah. So, kung wala kayong questions, yun lang kasi yung i-discuss natin for this session. For your final project, okay, lahat ng laman ng topics natin, kailangan gagawin niyo siya or ipapasa niyo siya sa akin sa final project niyo. So for instance, mag-discuss tayo ng arrays and then structures and pointers, linked list, stacks, queues. Lahat ng yon, okay, lahat ng principles na madi-discuss natin, kailangan may pasa niyo sa akin at the end of the term. That's why ngayon pa lang ina-advise ko na kayo kasi maraming topics involved dito sa subject natin. Okay? So, yung resources nyo naman, available yan sa internet. You could download it. Hanapin nyo lang. Okay? Clear ba?
Opo.
Okay. So, kung wala na kayong question, i-end na natin yung session. Okay lang ba?
Okay lang po.
Okay lang po, sir.
Ay, sir.
Yes.
Excuse me po,
Yes.
sir. Raise ko lang po. Si Bais po, hindi po siya naka-attend today kasi wala daw po silang internet. Nagre-reroute daw po yung PLDT sa